Okay, now on question number 14, I think before we actually attempt this question, we'll just remind ourselves of a couple of the rules that had to do with transformations of functions. So one of them is that if I was to take f of x plus something, so if I was to say f of x plus a, in fact, we'll do this with just an actual number because it's a bit easier that way. So if I was to take a function and then apply a transformation f of x plus 3, the effect of this is to translate the graph by 3 units to the left. So the translation vector would be minus 3, 0. So it's just another way to say move 3 units to the left. If this was, let's say, f of x minus 3 over here, then the effect of that would be to move this 3 units to the right. So we'll just so this is one of the transformations we are going to need for this question. Now the other one is the stretch along the x direction. So if I take f of, let's say for example, 4x, the effect of that is a stretch in the x direction, it's a horizontal stretch by a scale factor of 1 over 4. So stretch in the x direction can often be the more difficult one to remember. The scale factor is always a reciprocal of whatever this number is. So if I was to do f of, let's say, 5 over 4x, the scale factor is going to be equal to 4 over 5. So we'll just keep these two facts on a side here. So let's just keep this onto a side so that we can refer to them, and we'll then have a look at this question here. All right. So we have some function f of x is equal to 4x x minus 1. What we are told is that the graph of g of x, so a new function g of x, is obtained by doing two transformations. The first one is, it says that f of x is translated, it says translating the graph of f of x by 1 unit in the positive x direction. So one of the transformations, if you want to move something 1 unit to the right, so the first transformation that has been applied is f of x minus 1. Right? So in the same way that x plus 3 would move it 3 units to the left, f of x minus 1 is going to be this first transformation here. Right? So we're going to do that first, and then the second transformation, it says it's a horizontal stretch, so a stretch in the x direction by scale factor 2 over 3. So that's going to be the function. So we need to take f of 3 over 2 times x, because remember the scale factor for the horizontal transformation is the reciprocal of whatever that number is going to be. Right? So in this case, to find g of x, we'll apply the first transformation. So if I did f of x minus 1, so taking this as our f of x, so f of x minus 1 just simply means replace all the x terms by x minus 1. So this is going to be 4 times x minus 1 times this x here is also replaced by x minus 1. So it's going to be x minus 1 minus the 1 that's already here. So this bracket here simplifies to x minus 2. So I'm going to have 4 times x minus 1 times x minus 2. Okay, so that is the first transformation done. What we then need to do is take this function and apply the second transformation. Now, I think it will be easier if we first expanded these brackets, right? So what I'll do is I'll at least expand the two brackets here, but keep the 4 on the outside. So this is going to be x squared minus 3x plus 2. Right? So that's the first transformation. We then need to apply the second transformation on this. Right, so we then need to do f of 3 over 2x, so this one here. Right, so what this means is replace all of your x terms by 3 over 2x. So this x squared will now become 3 over 2x whole thing squared minus 3 times 3 over 2x and then plus 2. Right, so we then just need to expand these brackets. So when we expand the first bracket here, this is going to be 4 times 9x squared over 4. So just keep in mind that that's the same as 3x over 2 whole thing squared. So the 3x squared will give you 9x squared, the 2 squared gives you the 4. This bit here, so I still have to multiply all this by 4. So 3 times 3 would give me 9, so that's 9 over 2x and plus 2. And then finally multiplying the 4 into it, 4 times 9 over 4, so that 4 and 4 will cancel, so that gives us 9x squared. 4 times 9 divided by 2, so that's going to give me minus 18x. And then finally 4 times 2, that gives you plus 8. So the fully simplified answer for g of x, so the new function that we have, so applying both of these transformations to get to g of x gives us this equation here. Now, just like with part A, for part B, what we'll do is we'll start by just reminding ourselves what a vertical stretch looks like. So if you have some function, and if I was to put a number in front of this, so if I was to take 5f of x, the effect of this is to stretch in the y direction by that scale factor. So in the x direction, what we saw was the scale factor was the reciprocal, but in the y direction, if you have a number at the front, this would just stretch in the y direction by scale factor 5 in that way. Right, so we'll just keep this onto a side because this question does have a vertical stretch. Right. Okay, so this one is quite an interesting question in that I don't think I've seen one like this in a past paper. So what we had was, so we had f of x. For part A, we were told that there were some transformations done to it, and we got g of x from that. What we are told here is that the function f of x, this function here, itself is obtained by doing some transformations to some other graph h of x. So there was some function h of x, and there were some transformations done to it to give us f of x here, right? And what we are told is to kind of reverse that to find what h of x is equal to. So if we look at the transformations that were done to h of x, so it says it was translated by 1 unit in the positive x direction. So it was moved right by 1 unit. So there's a translation by 1, 0, followed by, it says then, followed by a vertical stretch by scale factor 2. So there was a vertical stretch by scale factor 2. Now, if you want to reverse that, to go from f of x to h of x, what we want to do is to reverse the stretch by scale factor 2, we'll need to stretch this by scale factor 1 over 2. And then followed by, so to reverse the fact that it was moved 1 unit to the right, we want to translate it 1 unit to the left, right? And in this case, the order will not matter because I'm stretching in the y direction by scale factor half and translating in the x. But I'll do it as if, you know, depending on the transformations you are given, it could be that the order doesn't matter. So in this case, because we did the translation first and then the stretch, to reverse it, we need to reverse the stretch first and then reverse the translation. So we'll then think about what are the two function forms that we need for this, right? So stretch by scale factor half. So the first one is going to be, we just need to take half of f of x because that is what will stretch in the y direction by scale factor half. So our function here is 4x x minus 1. So this is just going to be a half times 4x x minus 1. That's a fairly easy one to do. We just need to multiply the half into this bracket here. So that's going to give us 2x x minus 1. Right, we then want to translate this 1 unit to the left. So the thing that translates 1 unit to the left is x plus 1. So we want to replace all of our x terms on here by x plus 1. So this will be 2 times x plus 1 times by, if I replace that x by x plus 1, so that becomes x plus 1, and then we have another minus 1. So these two will just cancel out. So this gives us 2 times x plus 1 times by x, and that can be written as 2x x plus 1. You can expand the brackets if you want to, but this factorized form is fine.